Hello guys, I'm Arko Mitra, a software engineer at GeekyAnts. So today we would be talking about server-side events, and hopefully by the end of this video, I think you would have a basic sort of understanding about how server-side events function and their use cases. So let's begin. Now, server-side events, they are the polar opposite of traditional HTTP requests, which go from the client to the server. This is totally opposite, as you can see over here. We are streaming data from the server to the client. Totally opposite, right? Now, the same thing could be achieved by WebSockets as well. But WebSockets, they are duplex, full duplex, right? It happens both ways. It is bidirectional. Now, server-side events, they have many use cases as well. One being push notifications. Let's say you have a use case where you want to inform the admin of the website when a new user logs in, or they log in after a very long time, a pre-existing user logging in after a very long time. So for these sort of use cases, you want to send a message to the admin, right? Stuff like these, you can use server-side events. Now, over here, server-side events, they are only unidirectional, right? They only go from the server side to the client. So now that we see this, let's move on to how this works. So we see the client and the server over here. Pardon me for my very minimal sort of sense of illustration. So as we see over here, we first try to set up a connection from the client's end to the server. Okay, the first call happens. We first set up a connection request. We ask the server whether they are ready for a text/event stream sort of communication. So if the server is ready and available, it would periodically send off data streams to the client. Now, this sort of mechanism, it is allowed by every sort of web browser. All clients of every sort of web browsers, they allow it, but Internet Explorer still doesn't. That's one thing you have to consider. Internet Explorer, right? So after the data streams, they are like produced in nominal periods, the server can like close the connection, although we wouldn't like to close the connection. In ideal cases for websites to function, the connection won't be closed, right? It would send data streams forever unless the server goes down for some reason. We really hope it doesn't. So yes. Now we could come into the differences between server-side events and WebSockets, something which we were talking about a while back. So as we just discussed a while back, SSE server-side events, it's unidirectional. It's only going from server to client. Whereas WebSockets is bidirectional, allows from both sides real-time communication. Also, one thing to note, in SSE, we actually have a backdrop. It's being that there are limited connections allowed for a browser, 6 being the highest limit, as you can see. Whereas we don't have any such limit on WebSockets, we could have a huge amount of users. Now that we have brushed through the theory parts, let's go on to some code, right? So I have set up a very minimalistic sort of code over here. As you can see, this is the main function of the Golang code that I have written. I've just spin up a normal HTTP server having this server-side event handler, right? This would be working on port 8000, of course. So let's see the contents of our very own SSE handler. As we see, the writer, I mean, every request has a response and a request, right? Over here, the writer is the response, as you can see, and the request we are getting. You have to keep this in mind for such requests. I mean, for such events, server-side events. This header is the main prerequisite. All right, content type text/event stream. Since we are sending data in chunks from the server to the client, we are not setting any nominal size for these sort of data packets which are going from the server to the client. So that's why it's called an event stream. Data goes in chunks. So what we are trying to achieve over here is that if you are privy with the lingo in Golang, you would know about tickers. What do? They actually go upon the same function in periods which you can mention over here. In my case over here, the period I've mentioned is 3 seconds. The sticker is initialized. I have initialized a forever loop as well, which doesn't have any condition. So this for loop will go on actually forever. That's why forever loop. I've also added a channel over here, client not there. Let's say out of the 6 possible highest connections, if no connection actually is present, then this would be triggered, meaning client not there. So all clients are disconnected. Again, Please forgive me for this very minimalistic sort of design code. It doesn't follow any principles, so very sorry for that. This is only for you to understand the concept of server-sent events better. Moving on forward, as you can see, this update ticker, every time in 3 seconds, once in 3 seconds, we are falling into this case. This gets triggered, right? This block of code for this case, right? So what are we trying to achieve over here? What function are we trying to do? So over here, you can see an array of strings of all the places. Like there are 6 places, right? So we are choosing any place in random out of this particular array, right? And we are trying to fetch the temperature in Celsius for these places. And what would we show in the front end? We would show any random place out of these with their temperature in Celsius. So that's what we are trying to achieve. This is to actually show you that some change is happening in the backend, which is being communicated to the client to show the basic working of SSE, right? So that's what random place is chosen. We get the temperature data from here. It's just a third-party call to weather API, as you all know. I assume that you have worked with it before sometime. I mean, we all have, right? So over here, I have the place for the API key, the place name, which is the parameter of this function. The secret, unfortunately, I can't show you, right? Because it's the API key that I'm using, right? This is the search string. We are formatting it and we are calling in as a request, getting the response, and eventually it's all jargon. I mean, boilerplate jargon. You know how to call a get request, right? Now we get the temperature details, which would have the temperature in Celsius for that particular place, random place, which is passed in as the parameter of this function. So now we are coming to the main part. This is the data send template in which we format our string, get the random place and the temperature in Celsius. So we have this sentence: temperature for random place is random temperature for that place. Then what we do is a bit important for you to digest. We are going to write into the response writer for this particular endpoint. What we are going to write into it? We are going to write the event and the data, which is very important. We have to always mention a particular event and base to it the data for the event. The data being this particular string. As you can see, %s is the formatted string over here. For temperature for blah 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 is blah 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 Celsius. As you can see, event temp data. And if you see the front end code as well, which is also very minimalistic, please don't feel bad for this. As you can see, I have created a new event source for this particular localhost 8000 port and this endpoint SSE demo, right? From which information would come periodically thanks to this ticker. This event listener is added, temp data, as you can see. And from here, this event temp data, you're going to send this particular data, this temperature string, right? I'm going to console log it. It would show in your browser, which I'm going to show you once I run this piece of code. I also have a span of temperature, okay? This is going to be populated. This text content is going to be filled by this temperature for blah, blah, blah is blah, blah, blah Celsius. If there is any error, we would also do this SSE error with the error being logged out as well, right? It's just, completing the code. In the end, we flush out the data if there is any to be flushed out. So yeah, now let's run the code. Run main.go. So our server is running. All right, what we need to do is we need to check over here. Yep. As you can see, data is coming over here. Let's to explain this, I would say that since this was running, since this was open before, this already had added an event source. But since the server wasn't up before of course I ran the main.go code, it was constantly getting this SSE error because it is expecting the server to give us data on the other end, which it isn't. So that's why. Now you're seeing in the period of 3 seconds, this is constantly getting updated, right? Italy, Chennai. Also, sorry for the random ordering of places. I just added any place which came in my head. So that's why. So now you can see how server-sent events work. So, yep. Let's close this. To close this video, I would like to point out a few disadvantages as well. Something which I had already talked about, like browser support, which is limited. Internet Explorer doesn't allow server sent events to work. So over here, it is also more susceptible to cross-site scripting attacks since it depends on client to verify origin of the server, right? So that is also the new point. Also, one downfall of this is you can only send UTF-8 text data types. You can't send binary data, at least in normal scenarios when you're not using HTTP by2. So also these things you have to keep in mind. But regardless, despite all of this, I would like to say that server sent events are very much interesting to work with. And they do have a lot of use cases which you can use where I don't think WebSockets would actually, like the robust setup of WebSockets, you don't have to do that much. Like server sent events would actually take the place for that, right? You can actually use server sent events. Like the example that I just said, let's say stock prices, go up and down for a particular product or a company. So you can get this information in real time from server sent events, right? Every now and then in a period of, let's say, seconds, you can get or push notifications, like I mentioned in the beginning of the video. Hope how that you have made it to the end. I hope you have a better understanding of server sent events than you did before watching this video. If you did, it fulfills my purpose of making this video. So thank you. By this, I'm Arko Mitra, ending this video.